In this video, we'll once again be covering the trapezoid rule. Now, the trapezoid rule in this case will be looking at this integral going from x equals 2 to 5. Keep in mind that this time we're going from 2, not from 0. So it does change things ever so slightly, but it's not a drastic change. Now, in terms of starting at 2 going to 5, we will, again, you'll notice, find our delta x very quickly, which is b minus a all divided by n being the 5 number of rectangles that we're looking at. And the thing I'm going to do here is once again create my number line. Now, for this number line, I'm going to go ahead and start at the value of 2, no longer start at 0. Again, because I'm starting at 2, that's what I'm going to put here. I'm going to change that real quick to be 10 out of 5. The reason why I'm doing that is because since my delta x is in terms of 5, finding a common denominator will make this the most efficient way possible to finding my endpoints. So my next value that I would have is 10 fifths plus 3 fifths, which is 13 fifths. And I'm simply going to go ahead and add this 16 fifths, 19 fifths, looks like 22 fifths, and simply 25 fifths. Now 25 fifths, you'll notice, is the value of 5, which is my endpoint. So I don't need any of this extra values over here, so I'm going to simply go ahead and cross all that out because I don't need any of that. So you'll notice I have 1, 2, 3, 4, 5 spaces, and again, one more time, 5 areas then to find. But we're going to go ahead and use that little formula we did in the previous example, which was, again, 1/2 times delta x times f of x0 plus 2 times f of x1, and all the ones in the middle get that plus 2, while my last value doesn't. Okay? So using this formula, I can very quickly identify that this is going to be 1/2 times 3 fifths times f of 0. Now remember, our function is now x cubed, so I'm looking at this thing being multiplied by, I'm going to go ahead and write it this way, f of 2 plus 2 times f of 13 over 5, because that's my second endpoint. Again, 2 is my first, 13 over 5 is my second, plus 2 times f of 16 over 5. Now my third endpoint, remember, the second, the third, and every middle endpoint gets that value of 2 being multiplied in. So 2 times f of 19 over 5 plus 2 times f of 22 over 5, and then finally plus just f of 5. At this point, I would strongly recommend you use a calculator to evaluate the values of each individual piece, because what you're going to end up with very quickly and very carefully is 1/2 times 3 fifths is 3/10 multiplied by f of 2, but again, remember our function is x cubed, so this is going to be 2 cubed plus 2 times 13 over 5 cubed plus 2 times 16 over 5 cubed plus 2 times 19 over 5 cubed plus 2 times 22 over 5 cubed, and then plus 5 cubed. Remembering again that all the middle terms get that multiplication by 2, but the outer values do not. So by evaluating this using a calculator, we can identify very quickly, again, not the approximated, let me rephrase that, do not round this value. You will end up getting a fraction of some sort over values of 125. Do not round that off to a decimal value. The goal of this was to approximate the area under the curve using the trapezoid rule. Well, these trapezoid rules provide us an exact area under the curve that approximates this integral. We don't want to approximate this integral using approximation value and then round that approximated value. It'll cause some more issues for us. So again, in this case, this trapezoid rule will provide us with an exact number. Please make sure you identify that exact number utilizing the fractions that your calculator can spit back out.